Exponential functions applications. In order to apply the application of exponential functions, let's just remind ourselves on the basic graphs, the 4 basic graphs that we need to know how to sketch in exponential. The first one here is y equals to a to the power of x. It's a positive power of x. And the graph looks exactly like this. So I'm going to try and sketch that. And it's going to go through 1, coming and approaching 1 and growing exponentially. So because the constant here is 0 plus c, and c is 0, that's why the line of y equals to 0, that curve approaches it. And the coordinates here will be at the point of intersection on the y-axis. So that's your y, and that's your x. And that'll be 0, 1, which is x comma y. So that's the point. And those points, you know how to find it by putting x equals to 0 and y will be 1, because a to the power of 0 is 1. So that's the positive one. And the negative one of that one is when you have y equals to a to the power minus x. That graph looks like that. And it's coming to 1 and approaching y equals to 0 again. And that's your y. So that's what that looks like. And then that's your x. And this line again is y equals to 0. And this is 0, 1. And let me just put that graph on this side. So that's y equals a to the power of minus x. So that's number 2 graphs. That's the number 2 graph that you need to remember. So that's number 1. I just draw that straight. Okay, so that's number 1 and that's number 2. Now, number 3 graph will be, now we need to just stick minus in front of those functions. And then we can get those graphs. So y equals minus a to the power x plus c. Remember, c is 0. So because it's 0, approaches the line of, at the line of asymptote will be 0. Y equals to 0. And the graph looks like this. This is a reflection on the x-axis. So it's exactly the same thing, but it reflected on an x-axis. So it will be approaching like that. Okay. Again, the coordinate here will be 0, minus 1. And that will be your x, y. And that's your y. That's your y equal to 0. That's your x-axis. Right, so that's what that looked like. And for this one here, if I draw a line to separate it, and I have number 4, which is y equals minus a to the power minus x. So that graph, we need to know how to sketch it. We need to know how to sketch this one. We need to recognize that. And we need to recognize this one. So those are the graphs. So to sketch this one, it's similar to the one above, but that graph is a reflection on the y-axis. So it'll be coming up here, and then it will be coming exponentially and then decreasing function. We're going down, approaching the line of asymptote there, y equal to 0, because the constant is 0. As you know, the constant is 0, so that's why it's approaching the line of y equals to 0. Now, as I said, a typical exponential function curve, exponential function is y equals a to the power of x plus c. And the second term, if it's 0, so the second term c is the line of asymptote. So those are the 4 basic ones we need to know when we're sketching graph of exponential function. Right, now applying the applications, there are 2 types of applications that are really common in exponential functions. One is charging or growth. So that's the first application. Charging of growth. What are we charging? We're charging a battery, we're charging a capacitor. In physics, it's very common to do charging of a capacitor. And then, or growth of bacteria. So the typical functions in this case are y equals a naught into bracket 1 minus e to power minus bx. And then we can rewrite that function as, when you expand it, a naught minus a naught e to power minus bx. In this case, the variables are y and x. So when we're sketching the graph, we can see what we're sketching. Otherwise, we can use the same charging or growth for bacteria, which is we use number of bacteria is n, and initial bacteria n naught into bracket 1 minus e to minus bt. The t is the time of the bacteria, and that can be expanded to be n naught minus n naught e to minus bt. So n naught is the initial bacteria. Now capacitor Q is used for capacitor, and Q naught will be initial charge on the capacitor, e to minus c over cr, not c, t over t. Let's just get this off. So that would be t over cr right. Okay, so that's the for capacitor, which is common in physics, A-level physics. And so you have Q naught is the initial charge on the capacitor, and Q naught e to minus t over cr. So that's when you expand it, and that's the functions you use. A typical graph for this charging or growth is, if I draw this y-axis or n-axis or q-axis, and as you know, the functions here are, we said it's y and x function, here will be n and t function, and here will be q and t. Those are the variables here. Let me just write that off. Now, the graph of the charging will be a growth, then approach, a line of asymptote, and that could be Q naught or A naught or N naught. If the graph we're plotting, let's say the graph we're plotting is N or A or Q. So, it wouldn't be A, it would be Y in this case. So that's Y. So that's Y. And that would be X or T, T or X. And that's the line of asymptote here. So that's what the graph looks like when you're dealing with charging and growth using exponential functions. The second part of this is once you've done charge and growth, we want to do discharging or decay. Decay of a radioactive substance or discharging a capacitor or battery. In this case, the equation for that is if you're doing capacitor will be Q equals Q naught e to the power minus T over CR. Let's just write R clearly. And again, the variables are Q and T. And if you're doing the bacteria, that's not bacteria, or say if you're doing a radioactivity substances decaying, so that would be A naught e to the power minus B T, and the variables will be Y and T. So what does that graph look like? The graphs look like this. So if I have the y-axis or q-axis, and I have the t-axis or x-axis. In this case, when you're discharging, you're coming from a higher value and then decreasing exponent, this case decreasing function. So this will be Q naught or A naught. So if you're plotting Y or Q there, let me just write it clearly. So that'll be Y function, and that's Q. And the x-axis or t-axis, so in this case we're just plotting t. So those are the variables in this case, and that's what discharge looks like. And those are the two applications we have in exponential functions, which is very common to exams. Okay.